Hello all, welcome back to my YouTube channel all about VLSI. In our previous sessions, we have discussed about register abstraction level modeling. What do you mean by register abstraction level modeling and how this register abstraction level modeling is being built and what is this and how are we using this, and with one example we have seen this, and what are the things which are present in this register abstraction level modeling. We have seen this everything about the introduction thing we have seen, right? Now, in this particular video, we are going to see what is exactly present in this register database. Like what are we going to build in this register database, right? So in this register database, we have different type of classes which we are going to use. Those are all built-in classes. From that built-in classes, we are going to extend. Okay. Now, so we have something known as fields in our register database. Now, what do you mean by field? Now, before going to discuss about this field and everything, let us try to have a simple design. This particular design is going to have few registers. Let's say this is R0 register, and this is R1 register, and this is R2 register. Like this, we have three registers inside our design, right? Now, in this R0 register, let's say this R0 register is to indicate some parityness, or let's say some configuration, right? Now, this R0 register, let's say it is going to have two fields, okay? Let's say it is going to have two bits, okay? This box or this is known as a field. The small unit which we can see over here, this is nothing but our field, okay? This is what we need to configure in our register. In our register, we need to configure this particular field, okay? We need to update the value of this field, okay? Now, so the smallest unit inside a register is nothing but our field. Just now we have seen this. And what is the purpose of this field? The purpose of this field is nothing but it is used to represent a particular set of bits within a register. Example, a status bit or a control bit. This particular bits may be a status bit or a control bit or anything. Okay. Depending upon the specification, our field will decide the status or control or any purpose. And this particular properties, like it may be a bit width, or it may be an access type, or it may be this particular field is used to indicate whether it is a read only memory, write only memory. So it may be used to indicate any particular information about that particular thing, right? Now, so this is what nothing but my field. Now, uh, moving upwards, like the very first one, we are going to have a simple field, and moving upwards we will have a register. So inside our register we are going to have our field. We need to configure these fields which are present inside our register. Now, what do you mean by field? Field is nothing but this particular bits, okay, or this particular spaces. It may be let's say if we are going to have a register, let's say R3. Now this R3 is going to have a field, and this field may be 1 bit or it may be more than 1 bit. Let's say this is from 0 to 7 bits. This is also a field, okay? So it may be a data field, or it may be a status field, or it may be a control field, depending upon the specifications. We will see one example, right? So this is also one field, right? So it can be 1 bit or it may be more than 1 bit, okay? And this entire box which we can see, which is containing two fields, which is known as our register. This is nothing but our register. Now, so a collection of fields that are accessed as a single unit, which is known as a register, and the purpose of this particular register is used to represent a hardware register, right? So, for example, name, address, size are all the fields which are present inside our register and can be read or write, or read only or write only, or read write. Okay. For example, we can have a register which is known as control register, and which may have the enable, mode, interrupt. Like we can have a simple control register, and this control register may have the fields like enable field, mode field, and interrupt field. So depending upon this field values, the register will be updated, and according to the register values that has been updated, the design will work accordingly, right? Now, so this now what is this UVM underscore reg and what is this UVM underscore reg underscore block, that we will discuss. Now, what is the purpose of this new method is to allocate the memory, to define the register size, and to enable or disable the coverage. Okay. So the syntax is function new, string name we should pass, and super dot new name, and number of bits which we are going to have, and whether the coverage has been enabled on the particular register or not. Okay. So where we are going to use this new method and everything we are going to see, right? And what is the argument? We are going to have name and the size and coverage. Okay. And we are going to provide the logical name of the register, register width, and disable or enabling the functional coverage, right? And yeah, fields are not created and no addressing happens, and only basic identity plus size. That's it. If we are going to use this new method, we are just giving the name and the size, and we are enabling the functional coverage or not. We are not at we are not yet configuring our fields. For configuring our fields inside our register, we are going to use another method which is known as configure. Okay, so this using this configure method, we are going to configure the values of these fields which are present inside our register. Before going to configure the values which are present inside our register, the first thing we need to do is, first of all, we need to create this register. Then we are going to use this method which is known as configure for configuring the values of these fields. Okay. Now, how to configure this? We are going to use a method which is known as configure. Okay. And we are going to have all these arguments. This configure is a built-in method which is going to have this many arguments. So first one is parent underscore reg, that is where is exactly the field is present, in which register the field is present, and the size of this field, whether this is 1 bit, 2 bits, 8 bits, 16 bits, and what is the LSB position, and what is its access type, whether it is read type, read only, write only, and whether it is volatile or non-volatile, whether it has a reset value or not, has reset or not, and whether it is randomized or not. Okay, so those are all parameters we are going to pass it as in the arguments for this configure method, right? So this is how we are going to configure the particular we are going to configure this particular field. Okay, so this means it is a parent register. One means it is a field width. Okay, like let's say suppose if we are going to have a register and we have a field which is known as enable. Okay, so this is a field which is known as enable. Now what is the width of this enable? We are going to provide over here. One means the field width is 1 bit. Okay, next LSB position is 0. That means it is a little big endian. And read write, so we are going to provide over here, that means it is a read write access. And 0 means it is volatile or not, and reset value is 0. If you provide 0, then it is 0 is a reset value, and 1 as it has reset, and 0 it is non-randomizable, and 0 means it is randomizable. So like this, we are going to provide this particular arguments, and we are configuring this particular enable field. We are basically configuring this enabled field. So this is how we are going to configure it. So let's see one example and we'll just try to understand it more clearly. So I have one example. Let me, yeah. So I've created first of all a register which is known as controlled underscore register. The name of this register is control underscore reg, and which is basically extended from the built-in class which is known as UVM underscore reg. Okay. Now this UVM underscore reg is an object, so which is also extended from UVM underscore object. Okay. Now this control underscore reg is going to have three fields. One is enable, and another is mode, and another is known as status. So let me write down. So this control underscore reg is a register which is going to have three fields like this. The name of first field is enable, and second one is mode, and the third one is status, right? And so we are registering with the factory, and we have created a new function. About this new function, just now I have told you string name and the name, size of this register, size of this total register is 32 bits, and whether it can be included in the coverage or not, we have given. And within the build phase, we are first of all creating the instance of this enable. Okay, so now here you can able to see we have declared all these fields enable, mode, and status with one more data type which is known as UVM underscore reg underscore field. Okay, so using this UVM underscore reg underscore field, this is also a built-in class. So using this built-in class, we are going to create our fields. Okay, if I want to create a status field, then using this UVM underscore reg underscore field, and status. I'm going to first of all declare them. Okay, with which data type? With the data type UVM underscore reg underscore field. So status is of type UVM underscore reg underscore field. So like this, I've created all the fields with of type UVM underscore reg underscore field. Okay, so fields are created with the class UVM underscore reg underscore field, and registers are extended from the class UVM underscore reg. Okay, so here for the enable, I've created the instance. How to create the instance? Class name, type ID, create. Okay. Now after creating the instance of this enable, I need to configure it, right? So I'm going to use this handle name dot configure. I'm calling the method, and I'm providing this is the parent register, and one means number of bits. So here it is only 1 bit. I'm just configuring it, and the number of bits, LSB position, access type, volatile, reset value has reset, and is random. That's it. Next, I'm also creating the instance for this mode, and next I'm configuring it. So the number of bits is 3 bits over here, and next I'm also configuring this status register, that is of type and the number of bits over here is 4 bits. So like this, I'm configuring this particular field values. So this is how I'm going to create a register and create my field values over here. And the remaining bits, we can create more number of fields in our future, and we can allocate the fields, or it may be reserved one. Okay, inside this particular register, we have created 3 field values, and the remaining bits we can create in future, and the remaining fields we can create in future, or else we can keep it as reserved. Okay, so this is how we are going to create a register, and we are going to configure our field values. So that's about this particular video. So where we have understood how to create a register, from where we need to extend it, and how to create a field, and how to configure a field, and what is a new method and what is a configure method, and how exactly we are creating the fields, and what is the arguments which are present inside our new method, and what are the arguments which are present inside our configure method, right? So that's about this particular session. If you like this video, please like, share, and subscribe to my YouTube channel, all about VLSI. Thank you for watching this video, and in our next session we are going to see how to in next session we are going to see more about this particular UVM